Hey guys, so as we work on being able to solve stoichiometry problems that involve solutions, I have a lab for us that involves measuring out the mass of two reactants, and then we're going to predict which one is the limiting reactant and how much of the excess is left over. And then we'll actually conduct a reaction between those two, measure how much of the products we get left. We'll do a little stoichiometry, and we'll see if what we predicted for the amount of excess left over was actually correct. So I call this one the limiting reactants lab. So let's go ahead and take a look at some of this. All right, so in our lab, we are going to take some copper chloride, CuCl2, and we're going to react it with aluminum in the form of this here aluminum wire. Right, before we do that, we're going to measure things out and we're going to do a few calculations. We're going to dissolve the copper chloride in water, and we're going to calculate its molarity, its concentration. So let's take a look at the directions and see what it wants us to do here. The first thing it says to do is it wants us to measure out 0.5 grams of copper chloride. And I've done that ahead of time, and I have placed it in this here test tube. You can see this is about 0.5 grams of copper chloride. And the instructions say to dissolve this in about 10 milliliters of water. Okay, to do this, we're going to want to use distilled water, not the sink water. We want to use distilled water. So I have my graduated cylinder. I have some distilled water in this here squeeze bottle. I'm going to get 10 milliliters of distilled water. And we're going to put this in here and let it dissolve. Okay, if you're doing this in the classroom, you're going to want to measure out 0.5 grams on the scale before dissolving it in water. Make sure you get enough. We're going to let this sit for a few minutes, make sure it gets all nice and dissolved. I'm going to put it right in there so it'll stand up. It also wants us to find a length of aluminum wire. So I'm going to get a little length of aluminum wire here. It says on the instruction, I believe this is about 16 centimeters. It doesn't really matter exactly. Just make it about as long as your hand. So I'm going to take my wire cutters and cut that off. And we are going to want to measure its mass. We're going to want to put it on the scale and figure out how many grams before we do anything with this. So I'm going to do that right now. My wire weighs 0.65 grams. So I'm going to go and I'm going to put that on my assignment sheet right away so I don't forget it. 0.65 grams. Okay, now we're going to want to figure out, now that we've measured our copper chloride and we've measured how much aluminum we have, we're going to want to figure out which one is the limiting reactant and how much of the excess is left over. So let me look at my numbers. I have 0.5 grams of copper chloride and I have 0.65 grams of aluminum, and we need to pick one of those two numbers to start with. Doesn't matter which one we pick. So I am going to start with the copper chloride and see where that takes me. So I'm going to start with 0.50 grams of my CuCl2. Now, one thing you're probably not aware of at this point. Okay, this copper chloride that we're working with is what's called a hydrate. Okay, which means there are some water molecules stuck in the crystal structure of the copper chloride, and this particular type is what's called a dihydrate, which means there are two water molecules stuck in the crystal structure here and there. Right. So when we calculate the molar mass of this stuff, we have to include not just the CuCl2, but also two water molecules. And it actually makes it very easy because on the bottle that it comes in, it tells you what the molar mass is. So I believe it was, let me look real quick before I say it here, it was 170.5 grams per mole. So we don't have to actually go and add it up. It's 170.5. It's also on the lab form there. So I'm going to take this. This is not just CuCl2. This is CuCl2 to H2O. Yeah, I'm going to put that over 1. And I know that it's 170.5 grams to each mole. I'm not going to keep writing this out for each one. Right? Okay. In my third fraction, let me go to the chemical equation and let me fill in the coefficients there. So on the bottom, I'm going to want 3 moles of my CuCl2. And in the top, I'm going to want the other reactant here, which is 2 moles of aluminum. And then in my fourth fraction, I will go to the periodic table and look up aluminum. And as you can see there, it's about 27 grams per mole. So I'll put 27 grams on the top here and 1 mole on the bottom. Okay, let's work this out and then we'll analyze what we get and decide which one is the limiting reactant. So I'm going to take 0.5 times 2 times 27 divided by 170.5 divided by 3. And there I get about 0.05. So let's write this down here, 0.05, and that's grams of aluminum. Okay. So now I asked myself, if I'm going to use 0.05 grams of aluminum, did I have that much to start with? And oh yeah, I had way more than that. I had 0.65 to start with. So which one is the limiting reactant? It should be this copper chloride. It should be the limiting reactant. So I will say somewhere around here, you can write it on your lab paper where it asks that CuCl2 is the limiting reactant. I'm just going to write Lr for limiting reactant. And then it's going to ask us to figure out how much of the excess is left over. So if CuCl2 was the limiting reactant, aluminum is the excess reactant. If I started with 0.65 grams, and I'm going to use 0.05 grams, I'm going to expect there to be 0.6 grams left over. And that's aluminum. So what I'm predicting right now is after I do the reaction and I weigh that aluminum wire afterwards, it's going to weigh 0.6 grams. We'll see if it actually does. Okay, another thing it asked us to figure out on there was how much copper will be produced in the reaction. So after the reaction, we can collect the copper that's produced and we'll weigh it and we'll see if we're right here. So if you were watching the last segment and noticed that I had not included the copper in the chemical equation there, good for you. I just noticed it as I started to record this and added it up there. I just forgot to put it there when I was writing it on the board. So yeah. All right, so to figure out how much copper we're going to produce, we're going to start with the limiting reactant here. And we'll go to the periodic table and add up the molar mass, which it told us on the bottle was 170.5 grams. And then, of course, 1 mole up here. And then we'll go to that chemical equation. And so on the bottom, I'm going to want moles of the copper chloride, which is 3. And on the top, since they're asking us about copper, I'm gonna put the moles of copper on the top, which is 3 as well. 3 moles of copper. And then finally to the periodic table, and we'll look up copper, and copper should be about 63. So I'm going to put 63 grams on the top and 1 mole there on the bottom. Okay. Let me work this out and see what it is. These 3's cancel out. And then I will take 0.5 times 63 divided by 170.5. Okay. So I should be generating about 0.18 grams of copper. So hopefully, after my experiment's done and I weigh the copper, it should be 0.18 grams. We'll see if we actually get that amount. The next instructions on here tell us about how to go about conducting the reaction. Okay, I have my copper chloride that's been dissolved in water. I have my aluminum wire, And the directions tell me it wants me to make a hot water bath. And so what I've done is I've taken a beaker. I've taken a rather large beaker. This is a 600 milliliter beaker. I think the directions say to use a 400 milliliter beaker and put like 300 milliliters of water in it. Not that important exactly how big it is. This water does not have to be distilled water. We can use sink water for this. This is not going to actually be in our reaction. The only real purpose of this water is to be hot. Okay. Now, that said, it's an important safety note here. We want this water to be hot, but we don't want it to be boiling. Okay. If this water ends up boiling, then when I put my test tube in there, what's going to happen is that liquid in the test tube is going to get up to that temperature. It's going to boil and it could end up shooting out the top. I don't want that to happen. That's what these are for, by the way. Okay, so I have got my hot plate set somewhere between 3 and 4 on the dial, and that gets it up to where it's hot. That is very hot. Get it set up to where it's hot, but it's not boiling. So we don't want it to be boiling. So this is hot. We're going to put it in there. I'm going to time-lapse the video. You can watch it for 10 minutes. You won't actually watch it for 10 minutes because I'm time-lapse it, but we're going to observe it for 10 minutes. And then we're going to come back and we should see some copper formed on the aluminum wire. So let me put the camera in position. We'll put this in here and we'll see what happens. Okay, it's been about 10 minutes, and I can see that most of the blue color is gone from my solution in there. And you can also notice the copper that has formed on the wire. So I'm going to turn off my hot plate here, and I am going to recover the copper out of there and the wire. And then we'll weigh the wire. We'll see if we were right about the amount of aluminum that'll be left over. And we'll let that copper dry out, and we'll see how much copper was produced and see if we were right about that. So I am going to get a scoopula to kind of help me with the copper. So let's get this out of here. Here's the wire. We want to be careful and try not to knock the copper off of there. So there we go. And I am going to kind of scrape it off into this watch glass, and then I'll leave it in the watch glass to dry. And then we'll weigh it later once it's dried. Okay. Now let's go over to the scale and let's weigh our wire and see how much was left. Maybe I can move this stuff so you can see me weighing this on the scale. Okay, we're going to put our wire on here. We predicted it should weigh 0.6 grams after the reaction, and right now I'm at 0.58, it says. So we were pretty close, right? We predicted 0.6 grams, and it says 0.58. So that's pretty good. Now this copper, we're going to let this dry for a while because it's got a bunch of water on there. So we'll let it dry, and then we'll weigh it. We'll come back and weigh it and see, is it pretty close to what we predicted. For now, I am going to take these liquids here, and I'm going to wait for them to cool off, and then I'm going to dispose of them down the sink. Alright, so it's later now, and I've let my copper dry out. And this is amazing. Ready? Remember, we predicted 0.18 grams. 0.18. How about that? Right on the spot. That was pretty cool. Alright, hopefully that helps us be able to do our stoichiometry problems involving solutions. So until next time, take it easy.